All right, let's continue. So last time, let's see, it's blood on shape. Last time we started assembling the robot, and then we simply ran out of screws, sadly. So we had to take a little pause. But now it's kind of like more than a week later, and we have everything. We have screws. So we'll continue putting these things together. Let's bring it up just so I remember where things go. Yeah, there we go. Actually, pretty nice model. We did decent. I was thinking though that I forgot to put the switch for the battery. So that currently doesn't have a home here. It's just gonna be floating, which for starters might be okay, but we're gonna have to add something there. Now before we start, I just want to point a few things. So I'm doing a PowerPoint slide now instead of the Google Doc thing, but let's see. Yeah, some cool links I found this week, right? So first of all, this one, I'll put it here. I thought it was interesting. What's the difference between, this is a trapezoidal profile and a rectangular profile. And if you skip all the way to the bottom here, rectangular, acceleration, stop immediately at a certain point. Trapezoidal, my understanding is like start decelerating, stop, and maybe correct to the other side. But anyways, you can see here on the beer how one spills, the other one is perfectly flat. So I thought that was interesting, might be relevant to the project. So I'll put it there. This guy is a good follow. The other thing I was looking into was there's a few new models for image detection. I haven't tried this myself, but this RoboFlow Rapid apparently seems pretty capable. You essentially, it's like, before, back in the day, like, I don't know, 4 years ago, we used to have like YOLO V14 or V4, whatever, which could do some object detection, but it was like, it was basically as long as the object you were looking for was within the library or things the model had been training for, it could find it. This one apparently you can just do a prompt, so yellow cap for example, and it finds it, so pretty cool. And then there's another example here, or actually a different model, Meta Sam 3. I'll put this in here too. A similar thing, vision model, but I think slightly different, or well, I don't know, I haven't tried any of these, but you can see here it identifies, outlines the penguins really, really nice. Yeah. So it seems pretty cool. Seems like there could be an opportunity to use that on robots. Let me go back to this first one. I don't know if Rapid RoboFlow. I'm not sure if that's a model or it's based on something else. Let's see. Alright, I didn't know about this one. Looks like some sort of startup or something. Alright, very similar to the Meta one though. And then the other thing was this. So robotics LLMs, I think, or what do they call it? They call it a embodied reasoning task model, right? So embodied reasoning, I think that this can mean a lot of things, but essentially a simple example would be you put a camera on a robot and you ask the LLM, where should we go, straight, left, right, and so on, right? And so people have been doing it, like there's a lot of YouTube videos, people have been doing it all the way back since GPT-3. And they keep doing it every time a new model comes out. The thing is, it just doesn't work that well, right? Models are not so good at what they're calling embodied reasoning. And so now there's models specifically for that. And this one here from Google seems to be good. I don't know what these, I don't know what the benchmark they're using is, but it seems like that could be interesting if it works. Yeah, it could be interesting. I think the idea of having an LLM controller robot pretty well explored at this point, but it has not worked that well. So maybe this is interesting. And then there's like a whole blog post from Google here explaining how it works, right? So you can see that object detection, visual object detection is kind of like at the core. Yeah, let's see what kind of process. Describe in detail each definition task. Maybe they've made this more thinking towards robot arms. Place it with the coffee pot. That's crazy if you can detect stuff like that. Start handle detection and handle detection. That's pretty crazy. Okay, so I wonder. Okay, this is the same model. I wonder if this is already. This is publicly available. Yeah, you can start. Okay, seems like it is. So maybe something we check out. So that seems cool. And then the last thing I wanted to point out was this thing here. Open source robotics project. $600 bill of materials, supposedly. I think that's a little too good to be true. Hello, Hamini. Right, so last time we were looking at Sunday. Careers now, just Sunday. Right, so Sunday was cool because 2 arms, humanoid, semi-humanoid, right? No legs, just the platform. Right, and this is kind of like so far the open source version of that. Although it's significantly shorter, which will limit what it can do, but pretty cool to see it be open source. So yeah, some cool things. Always keeping an eye out because I'm starting to think, once we have this thing running, what's the next step? And there's a few ways. Maybe we can start plotting here. Right, there's a few things that we could do next once this is working. So number one, okay, so let's say it works. So PID works. So basic PID works, right? So basic PID works. Do more advanced PID. I haven't seen this myself, haven't done it, but I've seen it on papers where you can layer PIDs. Now, maybe that doesn't make sense since we only have one sensor here, but I just think there's more to controls theory than a simple PID loop. There's more that you can do. The other thing would be neural network to achieve balancing, right? So I think this would be interesting because one of the things that I didn't cross with the robot dog project was just let's call it the boundary of whether, like, train a model, sure, we were able to train a model, but then deploy it on hardware, right? That thing, that's something I haven't done before, so I think for that reason that'll be interesting. Then the other thing would be balancing plus control, plus user input control, right? So you can imagine you can have the robot balancing, and it's always balancing, but what about if you want to give it input, right? So balance while turning left, turn right, going straight, and so on. So that's that type of stuff. It's probably not super hard, but I just, again, haven't done it before, and I think it would be a good learning opportunity. Whether it's balancing through PIDs or balancing through neural network, how do you do both balancing and reacting to user input at the same time? I think that could be interesting. And then let's say it's the same robot, same platform for it to work, right? So it's just assuming we keep the balancing robot, right? Then the other thing is we could just build an entirely new thing, right? So new robot, always land on your feet. So this is an idea, like I mentioned it I think last time also, right? So okay, you can balance on the ground, okay, fine. What about balancing while flying in the air, right? So if you had something that you toss up in the air and somehow it always lands on its feet, I think that could be cool. Also, kind of like a controls theory challenge, right? Because I don't know, somehow you need to create inertia or counter the inertia to reposition, and you gotta do it quick because you're eventually gonna fall. So I think that could be interesting. I think that could be a little harder to implement just from the hardware standpoint, just because trial and error implies that you're gonna be crashing onto the ground a lot, right? So But that could be interesting. The other thing was so maybe something with all these vision models that I was mentioning. I should have put text. I realized I should have put text, but vision model, vision. Ah, wait. Vision. Ah, vision model. Vision model. Oh. Square versus trapezoid. Yeah. Embodied model. A lot of models. Open source Sunday. Alright. Yeah, so new robot always lands on its feet. Okay. That's kinda I always see it almost see that as a balancing robot but one step further. So that's one. New the other thing was something with all the vision stuff. I am not sure. Yeah, okay, maybe we'll go back to that, but I don't know. The embodied models, embodied AI thing would also be worth checking out. Like you can finally have, and I think that's some of them. Again, just judging by that blog post, it looks like they're more thinking about robot arms, which would make sense. But it would be cool to have something that you can just go around the house and kind of like not crash into the walls, without having to do a lot of sensor implementation stuff like that and path planning and slam and whatnot. Yeah. I do have a couple of SO100 arms, as I was thinking of hacking with that. Yeah, one of the things is like there's like these kind of like Tony Stark Iron Man 1 dummy, right? I don't know if I can play videos like these from movies. But essentially Tony Stark has this robot arm and it can tell things like, oh, hold these when it's positioned, for example, right? Or pass me these, things like that, right? So I have an SO100 arm. There are some cool vision models that can understand. Can I tell them at least hold this position, things like that, with voice commands? I'm not sure, maybe. That might be pushing it, but yeah. Basic, I will call it very basic controls. Hold position, alert, yeah, hold position, let's say. Anyways, we'll come back to this in the future. Ooh. What? Okay. Coolings, 12/14. Today is December 14th. Alright. Okay, that's enough. Let's just assemble the robot. So I'm gonna flip the camera from the top or something, and let's just finish this. By the way, huge upgrades to the desk. Now we have this stand here. Makes the mouse slightly better. And now we have light. I don't know if you can tell. We have a light coming from there. We have light. So I'm not in a cave anymore. Alright, so Amazon screws. There are so many beautiful reasons to be happy. always cool. Alright. Alright, so last time, yeah, we put this board on. That's always a mistake. We cannot put this board till the end because we need access to the holes underneath this board to be able to reach the bottom. So this robot is supposed to be assembled bottoms up. So first step, take this off. Now, I think we're using a combination of M2s and M3s. But again, it's been so long since we did the model that I no longer remember. And I don't think we documented these anywhere. So next time we document these. So we'll just try things out. Plus the holes are probably small enough to fit either anyways, so. Okay. Alright, so that's out. So bottoms up. We can start with, I might have lost one of these already. Oh, it's here. Alright, so we can take these off. Yeah, we can start with the buck converter. Right, so 4. We don't really need 4, but we said we'll do M3s, and we have M3 6 and 8. So it's probably enough to go with 6. Whoop. Don't need that much thread. And this is, yeah, it works, right? So the hole we make here at the top, on this level, helps us access the level underneath. And it would have been a huge mistake not to have that. Now, we don't need 4 screws for the board, but it would have been nice if, you know, some of the holes we're not using for screws, we could use as locating features. So instead of a through hole, it will be a pin coming out and help us locate the board. That could be an improvement for the future. I think that's part of the reason what differentiates someone new to mechanical engineering and someone experienced. Locating features. Alright, now these holes feel a little oversized. Didn't get a lot of thread engagement there. Almost feels like we sized for M4 potentially. But the board is in there, not a lot of play. Some play, not a lot. Alright. So we'll just keep going. So now we can do this one here. This one here is the power board, and you see you made this cut out here because we knew the cables were poking out on that side. So I think that was a good call. At the end though, the cables might need to move somewhere else, but I'm not sure. For now, let's just, I guess for now let's just assemble. And it's a good thing that we can still access the screws on those terminal blocks from this side if we ever needed to. Alright, more M3 6M. I wonder if maybe I can talk to this guy from Amazon, since they gave me their contact info, and tell them to just sell me the M3 6M. Oh, this one here, much better fit. The fastener engaged good. You have some torque. Oh yeah. Same thing here. Board has 4 holes. We don't need all of them. I think we're screwing over some of the wires. So maybe we're gonna back up a little bit and move the wires out of the way. Don't wanna pinch the wires. Plus, if in the future we need to move them, this would be a huge pain. So let's just do it right now. And yeah, perfect. Yeah, wire management is one of those things that it would be helpful to model it, but there's no super easy way to model wires on CAD, right? You're dealing with splines and stuff like that. So it's just often just don't do it and just figure it out on the spot. Which is what we're doing, which is gonna work, but I don't know, not the cleanest thing. Alright, now that that level is done, we can go on to the next. So I think we'll start with the motor controller. So the board here, we had it laying out. This is where the wires are getting a little stiff. We had it going this way. Some of the wires are intertwining. Let's see. What's the tightest thing? Tightest thing is the pi. The pi doesn't have to go to the motors. But see, we can't have this guy like here because these wires here are coming to this side, and this is where the Raspberry Pi is gonna be. So this guy has to be this way. And you can't see it, but it feels very tight to do it like that. These wires, these ones here, are getting tight. It's probably fine, but it's getting tight. Alright, now, let's see. Again, these holes look big, so M3. I'm thinking, what about M4? We could go M4. These are very long. These are these are still M3s, sorry. M4 are huge. Never mind, M4 will never work. Sticking with M3. A lot of oil in these fasteners. It's normal, but hands getting oily. Alright. Okay, so this is kind of funny. The holes don't really line up. So I'll take this out. And if you remember, this model we found online, we didn't measure, or I didn't measure. So it'd be kind of funny if, you know, I chose a model online, it just doesn't fit, just doesn't match what we have. Okay, so one of the pins here in the board is clashing with the wall here, a little bit, which I know on CAD we were mindful of that. Oh no, on CAD we have a clash too. Yeah, we have a clash there. Alright, so that's my first mistake. Alright, so we could remove some material or just push through. I think if this board sits slightly crooked, that's fine. The other thing is, yeah, the board holes are not lining up perfectly. So we grabbed a model online that doesn't really fit. But okay, it lines up enough where we can put two holes, right? So it's lined up in one of the directions, but not the other. So for now, that will be fine, but we can tweak this a little bit if we print another chassis, which hopefully we won't have to. But if we run into another issue, bigger issue, now we have two things to fix, right? We have this, and we have the fact that we have nowhere to put this battery switch. So at least two improvements that we could implement if we print again. doing everything by hand. Last time on the robot dog, we did everything with an electric tool. But this one's not as repetitive. So. Alright, so that board is on. So next, only 2 more boards to go. Raspberry Pi, well, and then we do the motors, but Raspberry Pi is supposed to go here. I don't know if you can tell, but no chance that goes through there. So I'm gonna redo some of the wires on the spot. Try to hopefully remember correctly where I took those out from. Trying to think here. This guy, the motor's in the way. Motor should not be in the way. Motor doesn't matter for wires. What's actually in the way? Not the IMU. I see. So all the, I guess all the logic stuff on the motor controller board is going underneath the power stuff, and that's getting very tight. So I'm gonna disconnect all of these guys. So it's green, blue, purple, white. And now we can reach. Now we can reconnect. Green, blue, purple, white. Green, blue, purple, white. And there's no way to mess this up because we have 4 pins. There's only, 4 male pins, 4 female pins. So only one way it can fit. What else? What else is tight? Power to the board is a little tight. Not great, but it'll do. Alright. And now we can bring back our screw swoop fasteners that we removed at the start. Oh man, so small. And it's starting to come together. I don't know if you guys are at the best angle to see this stuff. Let's try something else. It's kind of hard to have the perfect tripod thing. And this is where having a robot that just holds the camera, you know, like kind of like a smart robot arm, could be useful. Kind of like Tony Stark's one. That's why maybe future project. Alright, we're putting screws on. Not that one, here, this one. There's something to be said about clean wiring, and I don't have that right now. It will look so much more elegant if all our wires were neatly tight and the same color or color coded. Alright, last board is the IMU. You can see here we run into another issue where it's like these wires here are in the way of our IMU. And I don't have a way of fixing that. Oh wait, actually it kind of fits. Not ideal, but okay, it kind of fits. So that would be another thing to tweak. So now we have three things to tweak. maybe we start creating a list. This fastener is too big. This requires M2. And M2 is super small. That's fine. So I think it's the pi and the IMU that require M2. This is probably like the most important fastener because we don't want the IMU to be kind of like shaking around, right? Because that would introduce noise to our readings. Okay, so those are the boards, and then what's up is the motors. So the motors, you might remember. So the motor is supposed to go, I guess, this way. Let's check the ad real quick. Yeah. Oh no. Ooh. Yeah, the motor appears symmetric, but it's not. That's something important to keep in mind. So the motor goes this way. We have these pins here to line it up. Has holes here, and these line up like that. And that on its own is already pretty snug, right? It's like, oh, it's not going anywhere, right? So we do that on one side, do that on the other side. This side is tighter just because the motor is further away because the board is not centered. So now you can see the wires here are right in front for connectors, which is an elegant. Well, I guess they can be on the side. But yeah, I don't like what's happening wire management wise. We could clean that up a lot. But okay, so the motor is in there, both of them, but just with those pins, right? So now we want to put these brackets that we made to secure everything nice and tight. Yeah, so I guess, yeah, just like that. And you can see here, there's a little gap between it's hard to see, but here, gap between the plastic bracket and the chassis, kind of like to preload the fastener, at least in theory. In practice, results may vary. But again, I think this is overkill. This is overbuilt for sure. These things are not going anywhere. And then the last step for the motor would be to, I guess, to put the wheel, which just kind of goes in there. And then you can see these guys not going anywhere, right? Alright, and then we do the other side. Now that I put the motor on one side, doing the other side is harder. So maybe, no, you don't put the wheel, now that I put the wheel on one side, the other side is harder. So maybe don't put wheels till the end. Alright. Okay, nice and tight. Oh, I can put the wheel on now. All these fasteners are very prototype, right? These will eventually fall, lose torque. But just a prototype, so Alright, so this is in essence our robot. You can see it doesn't balance well, right? Yeah, kinda, but not really, right? So our CG is somewhat centered, but not perfectly centered. Well, sorry, I guess the one last thing we're missing here, and this might seem like a mistake now. Oh, I guess not. It's a battery. I was saying a mistake because we need to, okay, first of all, no locating features, right? So locating this, installing this is a little rough. But also we're gonna use screws to install these. So once the screws are on, if we wanna remove the battery to, like, for example, charge it, there is no way. We would have to remove screws, and the screws over time are gonna wear out, right? You can't really undo and redo screws onto plastic like that. So, yeah. Maybe a snap-on feature or something would have been nicer. Let's try and line things up here. So we have that. And I'm also seeing one of the shafts, because the motor shaft goes through the wheel side and also to the other side. So we're gonna be very close to the battery. It's hard to see because everything's white here, but you see here there's a shaft there and there's another shaft here. Those are gonna be very close to the battery, potentially rubbing on the battery, which this doesn't sound great. But anyways, this might be the one place where we actually use the 4 screws that we planned for, just so this thing doesn't fall off. Important. And then the battery wires on its own, you know, it's a mess. Those are short and stiff. And then the bumper makes accessing everything a bit difficult here. So I want to put on the screws first. Oh, I'm going to try to put on the screws first. So they almost act like pins to position the bumper onto the chassis. Almost, not quite. So yeah, so probably not want to remove the battery from the chassis after this. So if we're gonna charge, we're probably gonna charge on board. So we're gonna take the entire robot next to the charger. It's not necessarily a bad thing, but also not a good thing. Alright, little difficult to assemble since we have the boards installed and stuff. Trying to find a hole. Okay, there we go. Alright, so the locating of this bumper could be much better. And then we also have this harness for the charger that's just gonna be, I guess we can tuck it like that, but else it can risk rubbing with the wheel, which is not great. So yeah, so very tight package. We run into issues with wires. I mean, to be expected. And of course, we can always make a better harness for a better wire harness, right? This is mostly jumpers and stuff. It's like, it's as junky as you can get. We just want to see if it works. At least it kind of looks like a robot, right? It kind of looks like what we had in CAD. So that's good. Alright, I would say this is complete. Alright, so now as you can see here, balances, it wants to fall. The bumper doesn't let us touch the ground, right? We didn't calculate how many degrees this is, but essentially it's a stop loss, right? If you like the stock market, a stop loss. so we can learn without getting absolutely destroyed. And then if we were to connect everything, so we see the battery harness here, if we were to plug this in, it would be funny if it just burns down. I mean, it wouldn't be funny, but alright, so now we can turn this on. I don't know if anything's gonna move, but alright, you see a bunch of lights: IMU light, motor board, Raspberry Pi light, buck converter, lights. Raspberry Pi is red. I'm not sure what that means. Yeah, what does that mean? Oh, I think it means the SD card is kind of falling off. The SD card of the Raspberry Pi. Oh, it's not. It's actually well in there. Okay, it's green now. Anyways. Alright, so for the next step, we need to program this to make it stay upright. Alright, so you can see, yeah, it seems like it's mostly gonna work. Let's check the battery voltage real quick. I never get this right. Oh, that's loud. 25 volts, 4.14 per cell, 4.15. Alright. Seems like we're okay-ish. Yeah, this cable is too long. And I don't know where to put these. Okay. Maybe we can. I don't know, should we do zip tie? This thing is awkwardly long. I mean, it's not gonna matter for now. Yeah, we're gonna have it like that. Alright, so now we're hopping back onto the computer to program. Yeah. I guess the one thing is, probably lost most of the code from last time. Right, you can see, okay, it's essentially gonna keep itself like this, right? And then you should be able to move the ground a little bit, like for example, if it's here, I should be able to move these, and it should still be able to counteract. We will see. Alright, we're gonna switch cameras. Alright. Gonna fix the camera situation after Christmas. We're gonna have another camera. Ideally, I want something from the top, so we can see the robot. Anyways, I wanna add a list of things to fix. Things to fix on chassis V2. So we have three things. We said three things, right? So one is battery switch needs a mounting spot. That one's easy. We did it on the robot dog. You just make a little rectangle somewhere and it kind of like clips in there. So that one's fairly easy, and my bad we missed it. Number two, IMU. Now number two is wires from the motor controller interfere with IMU. We can just move the IMU in Y to clear, right? Get closer to the pi. So Y, yeah, if you have the two motors side by side, Y is the direction between motors. And then there was one more, which was okay, there's more than one thing, but okay, the motor controller holes don't line up with chassis. Plus there is a small clash on CAT with the pin on the inverse side of the motor controller. And then the other thing I would say was battery bracket should not use fasteners to mount to allow for repeated assemble and disassemble assembly and disassembly of battery for charging, right? I think those are the main ones. We'll see if we get to that. Hopefully not. kind of don't wanna don't wanna spend too much time on this guy. Yeah, the other thing I was thinking was, during hackathons, we would do these in undergrad. We would do projects like this in like one night. I don't know if we ever did like a self-balancing robot, but working with these motors and motor controller board and an Arduino Uno, and trying to get something going. That's something that we could achieve in like a couple hours, like 3 hours, 6 hours, depending on the challenge on a hackathon. Of course, that was a team of people, but I just feel like this time it took longer. And yes, the product looks better, and yes, it's much neater. Like the wire makes sense. There's a proper battery, much more capable hardware, but it's also taking much longer. So, all right. Next is open cursor. Let's see where we're at. Whoa. I don't know what it means when the Raspberry Pi 5, Raspberry 5, red light. What does that mean? A red light on Raspberry Pi indicates power is on, but a solid red light with no output is a common issue with a few possible causes. Solid red light. So we have power, but it's not booting. Solution: press the power button. I don't want to ask that. Which one's the power button? Generally, you have no idea. Raspberry Pi 5 power button. Sure. No, guys, I don't think we have that. Broke the power switch. The Raspberry power button. I'm not sure. Like the power button. Okay. We do have this thing on the side. Okay. Oh. So it went green for a little bit. Yeah, press it, goes green. Alright, maybe we chat with Grok. What does it mean when the Raspberry Pi 5 has a solid red light? I press the power button and it goes green for a sec, but then turns back red. I mean, obviously, insufficient or unstable power. Alright, well, let's check the multimeter. I guess it is possible that the board moved a little bit while we were installing, and we're not getting power, adequate power. So 25 volts going into the buck converter, confirmed, and $11.94 coming out of the buck converter, and then I think that way we're powering this was through the motor controller board. Oh. Shit, I know what's wrong. When I was moving wires from the motor controller board to create clearance, if we go back in time, I was like, remember I said green, blue, purple, white? Okay, the white one never got reconnected again. I imagine that's ground or something. I could check, but okay, so that's what's wrong. So now if I turn this on, the Raspberry Pi light should be green. Green. Alright, simple. Oh, it went to red. Don't know. Okay. One, two, three, four, five, six, 7. 1, 2, 3, 4, 5, 6, 7. GPIO. Wait, so what is powering the Raspberry Pi? We have common ground, yes, and then we have, I suppose, 5V. Okay, so the thing I said before was fake. I don't know, we do seem to get consistent 5B. My suspicion now is that, oh, actually I have no suspicion, that is correct, everything looks correct. Very odd. Alright, so it says insufficient power. Yeah, so I guess we can try connecting the Arduino onto, sorry, the Raspberry Pi, I can always say Arduino, onto my computer with a wire, right? And so if it's a power issue, I think that will take care of that. Yeah, still red. Still red, still red. What if we just I would cycle the battery? It's green now. Battery on again. Okay. So it does seem like a power issue. Kind of weird. Okay, so it's our motor controller is probably not a reliable power source. And so we're gonna have to fix that eventually. Or, sorry, it just makes no sense to have the camera here. You guys should be looking at the robot. But yeah, we're gonna have to fix that. I need to put this on the camera. I guess for now we can just continue to run connected to the computer just to get started with software. Because it just doesn't make a lot of sense why this isn't working. It was working before. Alright. Alright, we'll go back to that, but I guess another note here, right? So try things to fix electrical issues. Raspberry Pi 5 doesn't want to boot. Solid red. Solid red when relying on only battery. USB-C fixes these, but need to check how to make stable electrical connection with motor controller board. And this is why honestly using a Pi might just be a pain in the ass and we should just maybe have to use an Arduino, but or a better motor controller, I'm not sure. Okay. Alright, now if we open cursor, we will see where where did we, let's see. Man, I don't know if I remember the password. Super 23 Rust. Very high local. It's kind of been too long. Oh, we finally have to reboot my Pi because I can't remember the password. Okay. Keeps asking for password. Alright, well that seems to be it. It'll be funny if if I have to it'll be funny if we have to anyways, okay, last time we had IMU working and robots working separately. Right? And so as an example, where's our I don't get it. Terminal. Alright, ls cd robot. Alright, so as an example, we could run IMU test 5, right? And that should tell us, that should move accordingly to this, right? So if we look at A for acceleration, you can see here it's like 0, 0, and all the G is here on these axes. So this must be X, Y, Z. As you can see, we're perfectly aligned there. Oh, where were we perfectly aligned? And we also have roll and pitch, I think. So pitch is just about 0 here, because that's basically aligned, and then we let it drop. Sorry, pitch is still 0, so I was looking at the wrong thing. I think we're looking at roll then. Roll should be about 180. And that's where we think we're perfectly aligned. Right there. I guess. And then if we let it drop, roll goes to 152. On the other side, 163. Yeah. And then the G's roll, pitch. Okay. So yeah, the IMU data seems to work. Right? And then we can Command C these to close, or Command C, Control C. Alright, and then we can do Python servo pi. And that one moves the servo motors at like super full speed. And I don't know if these servos have, I don't think we can control speed. I think it's either on or off. And yeah, basically super fast or super not fast. We can ask cursor, which is, by the way, it's crazy because I'm not paying for it. Is there a way to control the speed of the motors? Yeah, I'm not paying for it. I also stopped paying for Grok and honestly can't tell the difference. So it seems to work just as fine. So I don't know. Worried for Elon. I would happily pay for all of these things. Adding PWM based control, updating code. I don't know if we can add PWM. Yeah, I'm not sure. I mean, this is where we pull up the motors. Motor, DC motor. Cheapest motor. Yeah, this thing. And then, doesn't really say PWM anywhere. Yeah. Whatever. I mean, we can just try things. We can just try. Oh, this goes very much more complicated. Why don't we try running that without even reading it? That works. The one thing I'm noticing. Alright, that worked pretty well. Vibe coding. The one thing I'm noticing is the wheels axes are not super straight, so it kind of like the wheels are a little crooked, but okay, I'll do fine. Alright, so just relying here on cursor, because it's cursor agent. Let's open a new agent window. It's like this, and then this. So I'll say we have means of controlling servo motors in a robot. We also have an IM view on board to, okay, using these two, I want to create a self-balancing Python script that combines the functionality of these two scripts. We can use basic we can use basic PAD theory to make these robots self-stabilize. The robot has two wheels on each side and can be thought of as a pendulum. Yeah. Let's make sure. Okay. All right. Let's start there. Let's see what happens. Let's see how easy is. I mean, while it does that, I'll do the basic stuff. So I'll set up a new file. I'll be like PID pi. Let's see. Review the motor. Then create. Okay. Wow, this is pretty good. Oh. Multimeter wants to go to sleep. That's fine. Now, of course, kind of sad to just let AI do all the work. But I mean, it's doing it so well. So let's see. Create a self-balancing script using. Make it a script. Wait, what? Why do that? Oh wow, interesting. I didn't even get to see what it made. Wait, do we want to do that though? Important. Hold the rotor upright when starting it. It calibrates the first second. The robot will try to balance at 0 upright. Adjust KP. Yes, if the robot oscillates, increase KD or decrease KP. If robots are slow to respond, increase KP. The script is great, you may need to tune the PAD. Okay, so I know that the right thing to do would be to spend some time writing the code. But okay. Alright, so I'm leaning towards one side, hoping that it would react. Oh wait. I think looks like we are using the wrong. Oh wait, sorry. Let's run that again. I didn't quite catch that. I think we're using the wrong axis on the IMU. So we're using pitch. We should be using roll or something like that. So pitch there is effectively 0. Here, pitch is effectively. Okay, we're vibrating a lot because of the motors, but effectively 0, but it shouldn't be 0. And then pitch here is a lot, right? So we shouldn't use in pitch. It's the wrong axis on the IMU. We should not be using pitch. Instead, we should be using roll, which the AI would have no way of knowing, right? Because the AI can't see, right? So that's part of the issue. Yeah. We need to go over all the code to understand it. We need to do that. We can't just push code, you know. Or I mean, we can, and this will be the shortest video ever. For once, we'll have a short video. This is really interesting. I have not touched cursor in, since like the robot dog days, almost like a year ago. And this, why verifying the context? I guess review. Okay, this review option is not great because I can't really. It's not showing me the diff, right? It's not showing me what changed. Everything changed basically. I would like to see. Okay, this was the diff. Alright. Roll rate. Okay, yes. Read IMU. I mean, okay, this is not. This doesn't really matter. Roll. Read IMU, okay. What is read IMU? Roll. Read IMU. Where is that coming from? Alright, def, read IMU function. So I was calculating pitch roll from, okay, so it's, I don't think this is gonna work. Let's see. Alright, let's try it. Maybe AI knows what it's doing. Okay, so next, okay, so this looks better, but I keep getting robot has fallen at angles 350 and such very high. I think what's happening is that our zero angle, is that the IMU goes from our 0 roll straight to 360 when it goes just 1 degree past 0 on the opposite direction. How can we fix this? Right, so essentially, instead of this being 0 and this being 1, 2, 3, 4, and this being minus 1, 2, 3, 4, this is 0, 1, 2, 3, and then this is 0, 360, 359, and so on. So it's a very steep drop, and it's triggering something. Sure, run this. Cursor is so good. I should be paying for this, I think. But I need, okay. Added normalize angle function. Normalize angles to 0. Yes, exactly. Apply normalization after collision. Yes. Okay, sure. I think that makes sense. Um, I say as I don't read the code and just run it. Okay. Alright, so what's happening here? I don't think we're reading. I don't think we're reading the right axis. Just checking here, motor controller is getting hot. There was quite a bit of trickiness there. Yeah, so we are not reading the right axis. Okay, so it still looks like we are not reacting on the right axis on the IMU. This is causing quite a bit of jerkiness, and I'm afraid of harming our hardware motors. Can we disable the motor reaction for now? And let's just print out the values for all axes and let me figure out which is the correct axis by moving the robot in real life. Let's see if we can understand that. Yeah. It's the MOSFETs here that get this block here with the heatsink, of course. It's doing all the switching, it's hot. I mean, heatsink's gonna do its job, but everything has limits, and the board itself is getting very hot. And of course, if the plastic touches that, it will melt. Yeah, so let's give it a little while. Maybe it's an opportunity for me to actually understand the code I'm writing. Okay, so alright, so now we can find our right axis, right? So pitch is not it, right? You can see here as I'm moving here left to right, the pitch value is not going anywhere, right? Roll seems like the right one. Yaw is not it, right? Yaw is, I don't know that. So it seems like roll is the right one. Looks like roll is indeed the correct one. Can you set it up so we initialize roll to 0 at the start of the script and don't move the motors, but print what motor input you would give given the roll value, right? So effectively, don't touch the hardware, but outside lean it. Let me know which way you think the motor should be moving, because one of the things that could be happening is we're going this way, and it thinks it wants to move both motors that way, but it might think both motors, our input of high move both motors the same direction, but it might be moving this one here this way, and then this one here this way. So that's one thing that could be happening. The other thing that could be happening is, well, we just need to tune the PIDs, and also there's quite a bit of jerkiness, and that seems to also obviously affect the IMU readings. But let's see what it comes up with. Okay. No, I should do that again. Calibrated it to the wrong thing. Okay. 24 degrees here, 19 degrees here. Funny, our battery thing is not centered. Okay, so over here, I need you to break the motor output specifically for each motor, so I can ensure we are spinning them in the right direction, right? So like still not, okay, let's see how we're doing here. Still super hot. Yeah, this this board is gonna die. Alright, so now it's gonna tell me specifically which motor is going which way. Let's try it out. Honestly, kind of hard to calibrate by holding it steady, so I don't know. Alright, so we're going this way. Left and right, left point minus 0.8, right 0.8. Okay, so you see the left and right are going the same way. Alright, so if we go back to our servo PA, I mean, man, I think I'm gonna go put this in the fridge for a little bit. Alright, because I just feel bad running this again. I don't know, maybe it's okay, but oh, everything is hot. The pie is also hot. So we're not doing much though. I mean, servo pie. Okay, so let's interrupt this for a little bit. Make a new window here. I would like to also print what is the output we are giving each individual motor at each stage. I want to verify what output equals what movement in the motor, so I can pair output to rotation direction. Now let's see if we can do that. While we do that, I want to check something. Am I paying for this? Because this is so good. I'm not. Wow. Editor agent. Interesting. So I imagine I have a fairly obviously sorry, oh, it's too many things. We'll come back to that. I was just curious because I feel like using it a lot, not running to limits yet, but Of course, I'm not really using it a lot. Alright, so now we can print that. But the speeds here, I'm gonna just run it super slow, right? Because don't wanna break anything. Yeah, just one dog, just one. Yeah, it's fine. And then no, and that's it. So Python servo.py. Right. Okay. Made a noise, didn't move. Sus. Okay, maybe 3% or 30%. No. Why is it doing that? Did I not save? It's possible I didn't save. Try speeds, test 0 speeds for speed. It's just kind of weird, but okay. Why do we have that? That seems redundant. Yeah, that seems redundant. Alright. Okay, well, it's going too fast. It's going too fast for me to catch what's going on. Let's give it 10 seconds. Both directions, same direction. Okay, so essentially if you give one, essentially they're doing the right thing, right? So output, so sorry, the input 0.3 here, both rotate on the same direction. So I think that validates what we're trying to answer. So we can go back to self-balance here, and we can run this one again. Right, so if we do these thing here, okay, so calibrate to 0 somewhere here. Don't know if that's right, but so here the left is 0.8, right is 0.8. Okay, so I assume both of them are trying to move this way, and then the other way will be the opposite. That makes sense. So that should be working. Okay. Guess the only thing is I'm worried of blowing up the entire thing, but other than that, we do have replacement boards. It just would be not fun to have to replace it. I want to make a copy of these for the future reference, and then okay, so okay, it all looks good. We can go back to moving the motors now. I wonder if it would make more sense to, instead of calibrating to whatever I set it, just using 0 and maintaining whatever the IMU reads as 0. Just keep that as sort of truth. Stop motors if the robot tilts more than 45 degrees. Print every, okay, the robot will cover it with use P80. Sure. Should we push it? Do we want to push it? very jerky. It seems to believe the robot is going to some extreme angles. Alright, so we want roll. So let's do a modification on these. Can you help me plot a chart in real time for the roll of the IMU? Roll PGR. Let's plot it in real life. I just want to see, what I want to see is if we do sudden jerks, what happens to that roll reading? Because maybe what we need is a filter, right? Because I don't see how else it's getting those extreme angles that it's seeing. By the way, a lot of mechanical play on our drive shaft, on our drivetrain. We got all, we can move a lot without actually rotating. Okay, I'm not gonna read that. Should probably read that, not gonna read that. No module matplotlib. Well, I mean, pip install matplotlib, I don't know what to tell you. Shit. I got the following error. Looks like there is no module in matplotlib. FYI, we are on a Raspberry Pi 5M. So it looks like this is actually a terminal now. We can run things here. I don't remember that from last time. I see things are failing. I just had a thought that maybe it's hot not because of necessarily the motors, but just the step down on its own might be making things hot. It is a cheap board, you know. Oh, Raspberry Pi died. Don't know why. Let's let it sit for a little bit. I'll come back to it. Let's let it cool down a little bit. Alright, it's a little cooler now. So I'll boot it up again. I was looking at my cursor, it turns out, yeah, I'm not paying. And even though some of these queries use 100,000 tokens, it's like 4 cents. So pretty crazy. But again, not paying, which is kind of weird. Alright. So, I guess where were we? We were terminal. Oh yeah, we wanted to. Oh, okay, gotta. Yeah, I guess the Raspberry Pi crashed. That's the last thing that happened. And then we wanted to make plots of the IMU readings to see if the jerkiness is coming from. Yeah, from some of the IMU stuff. Super 3 Raspberry Pi local. I don't know why it does this. It's gonna ask for my. No. Disconnected from. Why is it disconnected? We just connected. Super 23 Raspberry Pi. I should be asking for my password. There we go. Let's SSH, yes. You open that. Reload. Open remote, that should be connected. Sick. Password. Oh. Okay. Alright, so let's try this again, right? So IMU test by. Okay, so robot and then Python IMU. Like that. No module map click. Alright, so cancel. Okay. Help me fix this. I am in a Raspberry Pi 5 logged in remotely via SSH, by the way. And it should be an easy fix. It's just, you cannot just pip install stuff when you're in this environment. It has to, there's some certain thing that you have to put in. It's simple, I just don't remember the syntax, but last time we had the same issue. It's probably faster not to go through an agent for this. We could just ask, but too late. This is probably like costing like 50,000 tokens right there. While that loads, let's see cursor pricing. Second one. So there's a cursor web browser thing now. 1 week per trial, limited agent requests. Limited, but how many? It doesn't really say. Extended. That's gonna. This seems a little big. Limited agent requests. How many is that? And I can pay to get extended limits on agent, but how many? I'm not sure. This is taking too long. Is that actually working? Cursor, colleague, free, plan limits. Typically, not that I trust what Google's saying here, but vintage SH. What is that? Vantage. 50 requests. Dude, this isn't. I don't think this is working. Ask. No. Why are we planning next moves? I got this. Yeah, I mean, the scary thing is I have no clue what cursor is doing. But then again, it's just a Raspberry Pi. Oh, and it's so hot again. Oh, everything's hot. Which proves that it's not running the motors that's making things hot. Okay, so now we do this, and now we can install it. I mean, it seems to be working. Alright, so let's try that again. I need test by, right? So there should be like charts opening up. this is an agent, so it's not gonna fix it for us. It's just gonna output text. We have agent, plan, create detailed plan for, yeah. Plan, search, build, anything, okay. I don't think I never saw a plug window pop up when running this. Is it because we are on SSH? Yeah, it ran, but I didn't see any windows, so. Alright, we made things way more complicated now. I wonder what model is this? It's pretty fast. Okay, let's see. We're gonna implement, of course, without reading. Okay, plot say, oh no. Okay, oh, interesting. Okay, so this is, okay, so roll. Yeah, you see how it spikes? I think we tripped the, somehow we tripped the pi. We have a red light. So we have to power cycle, I think. What are common ways of filtering IMU data? I am using an IMU on top of a self-balancing robot with 2 wheels, and looks like cleaning up the data a bit could be beneficial. And then meanwhile we need to reconnect here. I was enjoying that chart. The commands are not working this time. I'm not sure what went wrong there. Super 23. Oh, the pie is still red for some reason. So that's not gonna work. It was very stable for a little bit. Low pass filter. external data reading for smooth up bumps from yes, or exactly. High pass filter. These removes low frequency components, say constant offsets or slow drifts. Moving average filter. That's also. Okay, let's see. Low pass filter. Let's Google for an example of a low pass filter. So, low pass filter, high pass. IMU example. Not entirely sure, but we can try it. Yeah, so let's keep working on the IMU stuff here. Raspberry Pi went red again, so we're going to power cycle. Not sure what we're doing wrong here. I think first, remote SSH. That's not really what we're trying to do here though. I don't think that's gonna work. Reload window, that might work. Let's see. Alright, we're good. Oh, I see a red light in real life here. Even though cursor makes it sound, I think we might be crashing Raspberry Pi. So again, we need to go to power cycle, I think. Or I guess we don't have to, I can just press that little button there. And then we can try again. I don't know if we can recover. Sounds like it's trying. Start simple, implement a complementary filter first. It's lightweight, yes. Alright, so as soon as, I'm gonna restore cursor. As soon as cursor opens, Raspberry Pi crashes. I'm not sure why that might be, because we're not running anything really. What would be the command? Remote SSH. We have no light on the Pi now. You went from, okay. Yeah, as soon as this opens, it goes red. I'm not sure. As soon as I SSH into my Raspberry Pi 5 through a cursor, the light on the Pi goes red. It crashes. Why could that be? Yeah, I'm not sure. Solid green, solid Paris fire, yes. Overheating. Could be. It's been harder, to be honest. Requires reliable, I mean it has reliable power. See what the battery said. .1, 3.99, we're still good. Okay, configuration issues causing shutdown login. Get trained cursor to behavior. Okay, so why don't we try not cursor, just a regular terminal. Alright. Let's try logging in from a regular terminal window, not cursor. How do I do this again? Right, so I think it's like, I don't think you can just go SSH here. I think it's a little bit more to it. Ping server 3 Raspberry Pi local. Can I do that? Well, actually the Pi is red again. I can see it thinking. The light is flickering and then it goes red. So that sucks. Yeah, we broke it basically. Maybe we turn this off. Okay. Yeah, I think it's time based, right? So I'm seeing the light flicker, green, green, green. And like, I don't know, it's like 20 seconds in, it goes red. Alright, it looks stable right now, so. Okay, so I'm connected. Okay, I managed to SSH on a terminal. It's only cursor that crashes it. What are things that I should check for? Info maybe? Options? No. No, power is good. Cursor locks? No. Can we do HTOP? Okay. Not as helpful. The MSG. I wonder when these happen now. Are these timestamps, I guess? I mean, that is useful. Okay, so we can have these open. Then we bring cursor. And see what happens. The light is still green. The light is red now. And it says under voltage detected. So we're connecting and it detects an under voltage. Okay. should be drawing though, just the IMU. But a way of fixing this without, destroying everything we built would be, first of all, let's check what voltage the buck board is supplying. 11.92. Input 24. Yeah, so the thing that comes to mind is removing the power to the IMU. Because what else could be drawing power other than the IMU, right? So I could remove these two. Okay. And then reboot. Because the motor doesn't draw power. It's only the IMU that's drawing power. The only thing that could be sagging the voltage. Alright, so let's bring that up again. I don't know how to recover the terminal window once we've lost connection. How about that? First we log into these, then we do what Grok suggested, which is didn't save. Where is it? DMS. Okay. And then we can go back to cursor. Right? See what happens here. Nothing happens so far. Okay, again, maybe. No error message. I mean, still nothing, but no error message. Supposedly attempted to reconnect. How long could that possibly take? I'm tunneling, it's not really working. New window. Let's see if this one works. No errors, but nothing loads either. Interesting. Yeah. Okay. Wait. Got an error here, but I don't think it has anything to do with connection to cursor server failed. Couldn't install cursor server, install script returned non-zero exit value. Reload window, sure. Alright. and the Raspberry Pi is green, so and we were able to connect here. So it's like a cursor thing, I guess. Let's try that again from scratch. You can see here it's trying. And then here we got an error. Failed to ping remote server. Socket closed without exit code. Let's try here. It's weird. What's that? It was working so well. This is what we get for running code straight from the AI. What is next? I'm gonna restart my computer or something like that? I mean, come on, you can't do that. Alright, apparently there's a SSH extension that we should maybe take a look at. No, but they are the latest for sure. Alright, let's try what Ravi here is saying. Because I don't think it worked, right? No. Alright, Raspberry Pi is still green, so let's try reinstall remote server and reload window. I mean, that didn't really. Remote SSH. Sudo 23. Reinstall server. That's an option. The Raspberry Pi light is blinking now. No new error. See a lot of failures. Connection to cursor server failed. Do we have to connect to cursor? Okay, so cursor. I mean, the thing is, these all happened a while ago. So steps to reproduce, connect from a server, disconnect from the session, either manually or due to network issue, attempt to reconnect, observe the error, confirm the reconnect only works after using reinstall server. When it's resting on server, we use the time it's locked. Could you try running cool old bash to force between? Do I run that here? No. Kill all bash. No matching process. No. Not sure. I'm not sure what happened here. I also don't understand why disconnecting the IMU made it stop crashing. And what if I reconnect the IMU? Do we go back to crashing? Oh, it's connected. Oh, but it crashed. Raspberry Pi light is red, under voltage. How much voltage can an IMU possibly be drawing? Yeah, that one seems hard to explain. And it's just a matter of more voltage then? Give it more. Let's see if this works. I mean, the other thing is we could completely wipe the Raspberry Pi, but that would kind of suck. Alright, you see it's attempting to connect, whatever. As soon as I connect these, it connects. Does it? Okay, now we're reinstalling the server. IMU's connected, we're reinstalling the server. This looks good. Why? I'm not sure, but it looks good. Like, why did it work this time? No idea. Something with the IMU, I don't know. Makes no sense. We are connected. bring back the thing Grok said. I need to remember this command. Alright. Anyways. I guess it works now. Alright, so it crashed. Why did it crash? No clue. Do we just start from scratch with an Arduino? I mean, surely we didn't have these issues. Code server script is not running. Create code server token. That seems good, right? I'm not sure. I'm not really going anywhere right now. Error install server. Failed to install server within the timeout. Install in progress. Sleeping. File exists. Pull. Man. Not sure. I mean, these are all failures, so that's bad. Alright, you know what? I'm gonna do the most boomer thing possible. I'm gonna restart. I'm sorry. I don't know. I don't know what else to do. I'll be back. I don't know, guys. Let's keep on trying. So connect these. Turn this on. It doesn't crash. You know, it's the little things in life. SSH from terminal. I mean, it's not reacting, but okay. Takes a little bit. Look for the error logs. Seems okay, right? So everything you would be like, oh yeah, this is fine. And then you did one of these, one of those. Raspberry Pi local. So far, everything is like normal. This is kind of like where the errors start. Connection to cursor to the server failed. Alright, so now you reinstall server. Right? Nothing serious. And it's doing it, right? So we're connected. Right? So that should be does it. We appear to be connected, right? Under voltage error, voltage normalized. We did not overwrite. Now we go here, right, home. Okay, ask for password, no problem. Seems to work. Maybe. We're on the agent thing. I think. Are we? Editor, agent, editor. We're on editor. Moves us to agent. Okay. So this seems to work. I'm just gonna change these. I'm gonna tell him to. Oh no. Siri, get out of here. I'm gonna tell him here to. No need to do the plotting. Just print values to terminal like normal. Okay, so I'm gonna stop looking at the IMU. Let's just go move motors. So let's clean this up because I think something here made us crash. So now that that's cleaned up, we should be able to go to the terminal. Alright, reduce the robot Python IMU test .py. Right, and so I think fuck. Oh shit, no, sorry. Still doing the plot thing. Do not do plotting. I don't want to use the matplotlib. I don't know why I didn't get that part. It's not using it actually. How are we generating a plot? We're not generating a plot. But it said plot will be saved. Plot will be saved. We're on the wrong file. Matplotlib. Yeah. Sorry, we were looking at the wrong file. Implement on this file. And I realized I'm just running tokens on agent on something very simple. Yeah. Alright, cool. Alright, now we do it again. Start time. Okay, there were more changes. Interesting, you can apply changes before it's done. Making changes. Alright. Yeah, 180. Yeah. Okay. Anyways. It seems fine. And now we go to self-balance, right? So now we can do Python self-balance pi. By the way, I can't believe that restarting is what worked. Waiting for the robot to be upright. I'm not sure what it means by that. Something is very wrong. Okay, let's try that again. To roll offset 149, right? So Alright. I'm gonna say we need to implement some sort of filter on the IMU data to reduce noise. at the very least, we probably want to use the accelerometer on par with the gyroscope, right? What do you suggest? Let's implement something simple for starters. Yeah, the balance regime doesn't really make sense, right? So as I grab it and I start rotating it, the readings sort of make sense, but then out of nowhere, we're like robot falling, the angle is past something extreme. And so I think the only way we're getting that extreme reading is because of noise. Complementary filter alpha, Giro Excel, okay. So now we're mixing both accelerometer and gyroscope. Complementary filter, okay. Complementary not because it's free, but it's because it's complementing two of them. We can try to see what this looks like. If all fails, we can always just ignore AI and do our own thing. Very basic thing. Okay, so it wants to go to this position, which is fine. So that's fine. It's just that we're off center by way too much, right? So 30 degrees. Okay, so another thing. Instead of self-centering instead of what do you call it? I guess you call it calibrating the IMU at the start. Let's always take IMU roll minus 80 degrees as our zero, and let's have a parameter in the code that I can use to manually offset that as required, right? So we already know that everything's pretty squared up, so let's take the zero from the IMU as the absolute source of truth, and maybe if it's slightly off I can tweak it a little bit, but for now let's not do the manual calibration because I'm just holding it wrong basically. Yeah, so all the calibration routine can go. Roll offset 180, okay. See, I don't know if it's 180 or minus 180, okay. Yeah, I think that would work. So I'm gonna hold it up. So, okay. It looks good. It's kind of doing the right thing. Okay, I see the issue. The motors are spinning on the wrong direction. So motor output, let's see how we're controlling. Sorry. Okay, let's be much better. Let's be encouraging. Now the motors appear to be spinning in the wrong direction. Let's flip it. Yeah, because I think it has the right idea, right? So it's reacting positively, and the magnitude of its reaction seems correct, but it's doing it on the opposite direction. Simple change, no big deal, I think. Yeah, that took 1 second, of course. sure to save before running. Run it. Okay, 0 somewhere there. Alright. Okay. Okay, you saw that? Did you see that? Did you see that? It was doing the thing, right? Good. Alright, so I think that is a matter of tweaking PIDs. So, alright, so we can ask, how should I think about tweaking parameters KP, KI, KD based on reactions I see in real life? So basically what we're seeing is like it was jerking like this, right? So, alright, so this is where PID tuning I think goes in. How aggressively a roll responds to angle error, right? So the proportional, it's very aggressive, right? It's like here, like this, and it's jerky. So it's too high oscillations, overshot instability. So I think KP is too high. KI, eliminates steady state error, resistant offset from target. Derivative, damping, opposes motion. I think we're gonna start with lowering the KP to 10, from 15 to 10, right? And so now, I don't know if you can see that. I don't know if the camera's catching that. It's pretty funny. Yeah. I mean, it is doing the thing for a little bit, and then the oscillations just get very bad, right? So we're gonna keep dropping the KP. This might be a mistake, but from my little experience, I mean, I would still say drop the KP, but I'm not sure. Yeah, right? It's balancing. I think we dropped the KP too much because now when it's there, it can't balance itself, right? So let's see, go back to 5. And I guess you gotta start from balance. Yeah. What else? Add KD for damping. Derivative damping opposes motion. Too slow oscillations. Too high slow response. Okay, so maybe KD now needs to go up from 0.8 to 2, maybe. I still think KP is too high. KD too low. KI eliminates steady state error. Too low, robot can never quite reach 0. I want to see what a high KD would look like. I don't know if I can, if I would say that's actually working. Can these be even lower? Or KP 0.2? The other thing we can do is we can set KD and K, oh, sorry, you can say KD and KI to 0. Probably we can't, or maybe this is too low now. Oh, the Raspberry Pi crashed under voltage. Let's try to reboot here. Let's check the battery. I feel like we're getting there, but at the same time, not really. Alright. Not a ton of experience in case. Reloading the window. But yeah, it's just good to try what happens if, you know, you set things to 0 and so on. The Raspberry Pi crashed again. We're doing that thing now where once it crashes, it doesn't want to come back. I don't know, because it crashes at an unstable state, I imagine. I don't know. I'm not sure how this makes any sense. I'm running out of time though. I will say that. Oh. Yeah, it just immediately crashes. Not sure. I don't know. Close cursor. Last time restarting the computer worked, but you know. Get the tuning for a self-balancing robot. Segway, basically, right? Balance control algorithm. Oh, that's funny. That's very similar to what we have, except ours is a much nicer package. But just want to see what values this guy had. Full code. Okay, see, the Raspberry Pi loads fine when cursor is closed, and it's like when I bring it's cursor that's crushing it. I don't know. I guess we gotta reinstall the server. Completely fine with doing that every single time, I guess, but yeah, it already crashed. Crazy. Alright, so I have an idea. So something on cursor makes Raspberry Pi crash. Anyways. think that you'll never stand perfectly upright, and that should not be the goal. In the final system, I think the motors will have to wobble. Raspberry Pi does not want to come back. Looks like your system is not stable. I hope you have to switch the system of your robot before directly going for tuning, which means that both sensor and actuators are responding properly. Yeah, of course. With acceptable error, well, I mean, and slowly to cut down steady state error, if any, and use T only when required in case of oscillation. I would suggest to handle P, I, and D one by one instead of clicking all at the one time. Alright, sure. Whoa. I mean, see, this is exactly why I'm doing this project. To learn this stuff. And I know, you're gonna say, you're not learning if cursor is doing it for you. To which I say, remote SSH. Connect current window to host. Not necessarily. Connect to host. Sure. Without crashing it. We need an option. Connect to host without crashing. Already crashed. I don't know. What am I supposed to do? Restart the computer? I mean, that's kind of not the point. What about killing all the cursor processes, but making sure they're all dead, right? Because I think if you close cursor, oh my god, if you close cursor, I imagine there's still cursor things running in the background maybe. Just this one. That one doesn't seem like it would matter. Yeah, you would think that doesn't matter, but I'm telling you, like, that's restarting is what works, so. And I'm getting annoyed that it's not good. Dude, I mean, DMSW. Oh, what is that? Are we all running the same setup essentially? How did you see the motors there? KP minus, no sorry, 23. I immediately went down, but I mean, it's hard to tell, right? I imagine these values are hardware dependent, so you can't really just be like, oh, these values work for this guy, so copy it. That's not how it works, I think. But having a stable platform to do this stuff would be nice. Okay, so we're connected here. Why did it connect this time? I'm not sure. Okay. Yeah. Seems to work. Did not crash. Okay. I mean, what did I learn? Don't make this 0, I guess that's what I learned. CD robot and then Python self balance pi. Alright. No. It's not reacting. That was weird. Yeah, it's not reacting. So the loop, it's stuck in the loop. Try to count 0, start time 0, while true. Okay, I mean, okay, what? Is the value too high now or something? I mean, this. Oh, sorry. I realized my mistake. Okay. I made the loop time longer. And I was going in the wrong direction. I think our target angle is slightly off. You can't smell this, but I can. It smells like plastic getting very hot. Something's burning. There, the Raspberry Pi crashed under voltage, which is odd. But yeah, I guess we just need a better. They were not joking when they said that the Raspberry Pi is very sensitive to under voltage. We need a better Raspberry Pi power. I mean, I guess we could. How do I power my Raspberry Pi 5? I'm using a USB-C, but it's not working. Raspberry Pi 5, how to power. We have some different type of connectors here. Those are borrowed connectors, we don't have thermals. No. I mean, maybe instead of powering the camera, I power a Raspberry Pi with this better USB-C charger. Should be super overpowered. Oh, I don't think it wants to take it. It doesn't even want to boot now. I wonder if I harness too much power. So it needs enough power, but not too much power, you know? Yeah, now it doesn't even want to react. So I wonder if I broke something. Green. The Raspberry Pi is very finicky compared to an Arduino. It gets hot, it needs the right power. Too many things, man. Maybe my fault. Should have gone with the. Okay. I think the thing is, you gotta close cursor. You gotta connect through terminal. Once you have that connection, only then you can take it to cursor. Not sure. Alright, so we have that connection. Let's ask Grok about this. I am finding the Raspberry Pi 5 to not be a great board for prototyping. It gets hot. It's sensitive to voltage sags. I am coming from an Arduino Uno. This sucks. How can I make it better? I mean, obviously it's like a simple issue, right? Someone has already fixed this for sure. Or I'm doing something terribly wrong. Also, oh, it crashed. Both of which are possible. My fingers are cold, so I'm cooling down the pie. I think basically I just need to restart like 10 times and eventually it works. Oh, crashed. We were doing kinda okay. Anyways, you see how we were doing like a lot of these. There was a comment saying that the goal is not to stand upright. The goal is to kind of we'll always wobble a little bit, right? That we're looking for that motion, that smooth motion. I think we're not looking to like find the perfect thing and hold it type of thing. So it looks like their official power supply uses that USB-C Type A. USB Type A ports to power. Which we could do that too, but I just a little bit disappointed. Are we connected? Can't tell. It kind of just like stops working. It's very annoying. Okay, now we're connected. It's weird because it's connected here, but it doesn't want to connect here. And if you close that, oh, this is not gonna work. Okay, it worked. But and we crashed. I'm not sure. Am I doing something wrong? This has been like 20 minutes now like this, just Raspberry Pi 5 cursors, it keeps crashing. Let's see if someone has connection crashing. There's a possibility that in the memory the problem took too long to appear as service. I'm just checking here if there's anything that's like, killing the memory. Like, is that why we're crashing? I don't think so. Okay, and as we connect here, does anything happen? I mean, memory increased a little bit, right? Memory usage, I mean. And we crashed. But without a spike here, at least we didn't see a spike. So I'm not sure. Yeah, I'm not sure here. Feels a little hopeless. Just doing that crush this guy. That's crazy, man. I don't get it. Don't get it. I think I need to spend some time. Hmm. All right. Maybe. Old thread, but that guy on the cursor forum was talking about forcing a reinstallation of cursor server. So we can try that. We can try that. I'll just go in here and break things, right? No big deal. Oh, it crashed. Alright, so I guess the question is, how do I connect to my Raspberry Pi 5 through the terminal and see all of the files in it? I want to delete a specific folder. Right, and so I already know the first step. That's not the first step. The first step is to connect, right? We're gonna connect. Right, okay, sudo raspi config, sure. Oh, wow, no. Oh, there's like random shit being printed on my. Okay. Yes. Right, go to interface. Okay, enabled. Oh, obviously, we already have that, right? Yes. Obviously. Okay, find Raspberry Pi. Yeah, yes, search and browse. Okay. I don't understand why things are being printed. I don't know, where did I wonder where random things being printed. Is it normal for random stuff to get printed on my terminal as I am writing stuff? I actually don't know where the cursor folder is. What is 4157 M0? one of the ooh, well, I didn't see that, but one of those cores was maxed out. All right, is there any Python running here? Okay, is there any cursor running? Nothing cursor. Okay. Okay, so we can lead with these apparently. Cursor server. And then remove RF. Cursor. And yeah. Alright, and now we can go to cursor. And we try to connect. And what do you think is gonna happen? You should not be able to connect. There's gonna be no remote. It has to install the thing, right? It has to install. Okay, well, Raspberry Pi crashed. It's red light here. So that didn't do anything. By reinstall Raspberry Pi with all native 64 fix from Chris was trying to use 6, but it was okay. Let's see if Grok can help me explain this. And then let's see what we installed. Can you try to explain these to me in the context of troubleshooting a Raspberry Pi 5? No. I don't know what I installed though. How do I know what is installed? White matters. Okay, this is it. Yes. Okay, running a mix setup and how do I find out what's installed on my Raspberry Pi? Cursor, Raspberry Pi, 64-bit. Cursor amp up image. Alright. there seems to be some issues. I don't know if this is the issue though. Alright. I guess ask Grok. Raspberry Pi 5. How to retrieve crash logs. Okay. Do I need to first SSH to the board to retrieve? I mean, obviously the answer is probably yes, but I don't know why this terminal keeps getting random stuff. Alright. I get the phone. Advanced options. There's more. Login. Persistent. Alright. What about now? Okay. 5/3. So that is right now basically. So we need to make it crash. So let's make it crash. Normally this makes it crash. Yeah, this looks similar. Update the latest version. I mean, sure. We can try that. There's no updates available or a latest version. Alright, it crashed. Restarting. And let's try it again. this is when, honestly, I just return the Raspberry Pi and switch it to an Arduino. Are previous versions of Raspberry Pi 5 more stable? For example, 3 or 4. I can't imagine. This thing got popular. No more stable, guys. I see, so it's my fault. Okay. Splash command line reboot coherent. I don't see cursor here. I don't know, is that the right one? Splash. Because I'm not sure what I'm looking for. I don't know. I'm gonna stop the video here. Try things out. There's no point in this, so I'll be back. Alright, so I spent a little more time on this issue. Still not able to get it to work, even though, okay, it's nice to have the robot assembled, but can't get it to work. Of course, my first thing was, oh, this must be cursor, because, I don't know, it seems to cursor was the thing that was crashing it. But then I tried VS Code, and it's the same thing. So I think it's gonna be, I think the other issue, and this is something that keeps coming up on all Raspberry Pi forums, especially Raspberry Pi 5, is the power source, right? So how do you power this thing? Apparently you need a constant 5P, 5 amps. Then right now I'm using my computer, my MacBook Air, through a USB-C, and that's up to 3 amps, and then this buck converter. And so I was thinking, yeah, I was getting these low voltage detected, right? Low voltage detected while doing nothing, just uploading code. And so I think everything's pointing to this to be a power source issue, which is annoying for 2 reasons. One, it's another thing I have to buy, and so I was shopping for one on Amazon. There's an off-branded one. Off-branded just because it ships faster. Also, you have to, you know, pay for shipping way more. So this is gonna be overnighted, maybe tomorrow. We'll see. It's annoying because I don't know if I'm gonna have time on the weekday just because of work to finish it. But I'll probably finish the video here. robot is assembled, it looks good. But okay, maybe this will work, right? Maybe, right? The issue is actually, how long is this cable? I don't think it says. I should say here, 47 inches, right? So, what is that? 4 feet. Like, it's not super long, right? So, how are we ever gonna power these off battery? I don't think our current electrical setup can do that, right? So, if we look at what we have here, essentially, we are powering through this board, very cheap board. That's not gonna cut it. So, I'm not sure. We're gonna need something else or switch boards, essentially, right? Yeah, so I want to spend some time see. I mean, this guy looks like they have more stuff. Like, we obviously don't want to add more boards. Like, that seems not great, but we might have to, or we might need to get a better back converter for maybe. Yeah. So that's where we're at, right? So 5B. No, that's not what we did. Yeah, this is what we did. 12B. Yes. Okay. Yeah, because this port needs 12B. This port needs 5B. So what? 2 buck converters? I mean, maybe. I don't know. I need to like shop around, but yeah, we have a power issue apparently. And so what I'm thinking is we finish the balancing section with just with a cable, right? We'll always be connected. And that'll do for now. And then, so we do need to figure out something to power this board, right? For the future, if we're gonna continue developing Raspberry Pi 5, we need something, which I think we should. I think it makes sense, but yeah. So pretty annoying. I'm gonna order that. Finish video here. Follow up when when we have that. So a short one today and not a lot of progress, but that's a reality. And I think we learned something about Raspberry Pi. Like, yeah. Anyways, see you next time.